So welcome to our last lesson in our Roots and Powers unit. It's 4.6, Applying the Exponent Laws. So we've been looking a little bit in grade 9 what happens when we're adding or subtracting exponents and happens to the powers. So we're going to come up with a list here of 5 exponent laws that we can use to solve complex problems. First one is called the product of a power. So in this case, you can see that I have 2 exponents. The base is both a, so the base of this exponent is a, the base is this one, is a. So when I have 2 exponents where the base is a, I take the powers, the m and the n, and add them together. So I'm looking for same base, I add the exponents. Next, we've got the quotient of a power, and quotient of course means division. If I'm dividing 2 exponents that have the same base, base is a, so if I'm dividing them, I'm going to subtract the powers, m minus n. Numerator, subtract denominator. So if I'm multiplying, I'm going to add. If I'm dividing, I'm going to subtract. The next one is called the power of a product. So essentially, I've got an exponent here. I've got a base and a power, and I'm raising the entire thing to a power. So you think power to a power. Power to a power, I'm going to multiply. So if I am multiplying powers, add them. If I am dividing exponents, subtract them. And if I have a power to a power, multiply. Add, subtract, multiply. I'm going to put a little line here because these first 3 are kind of related. They're all about what I do to my powers. These last 2 really are dealing with brackets. So in this case, I've got a product, so I have a multiplication inside my brackets, and everything inside the brackets is raised to the power of m. So essentially what this means is that I can distribute this m to both the a and the b. So ab to the power m can also be written as a to the m, b to the m. So everything inside the brackets gets raised to my power. Same thing happens if I'm dividing inside my brackets. A divided by b. So again, the m can be applied to everything inside the brackets. So the m can be applied to the a and to the b. So I would get a to the m divided by b to the m. So in these 2, essentially what we're saying is everything inside the brackets can be raised to a power. Let's look at examples here. So g to the 3rd times g to the 4th. Well, my base is g, my base is g, same bases, and I'm multiplying them. So this really means g to the 3 plus 4. So if I'm multiplying the bases, I add my powers. And of course 3 plus 4 is 7. So that really means g to the 7th. Okay, here's an example of the quotient of powers, where I have the same base, but I'm dividing. Same base and dividing, I'm going to subtract my powers. So this is like g to the 8th minus 3, which of course is g to the 5. Next example, I've got g to the 4th, which is an exponent, which is a power involved there, all raised to the power of 2. So power to a power, I multiply. This is like g to the 4 times 2, which of course is g to the 8th. And then I've got an example of the product, power of a product, where I've got multiplication inside brackets, all raised to the power 5. So the 5 can be applied to both the g and the t. So this would be like g to the 5th and t to the 5th. And finally, I've got power of a quotient where I have a division to a power of 4. This again could be g to the 4th divided by t to the 4th. So my fraction really stays the same, just that now each numerator and denominator gets raised to the power of 4. So if I had used a number here rather than g, let's say this had been 2 to the 3rd times 2 to the 4th, well, that would be 2 to the 7th, which would be 2 times 2 times 2 7 times. So 2 to the 7th, we could then bring that down to 128. So you definitely want to work out all the numbers that you can in order to get your simplest terms. Letters I can't do anything with, but numbers I definitely can. So these by themselves are fairly basic, fairly straightforward. The fun starts when we start combining these together. So let's look at a few here. I've got 2x squared y to the 3rd all to the power of 3 times 3 y to the 4th. So the first thing you're going to ask yourself is, what do you see here? Well, I do see I've got an exponent, or power to a power, so I'm going to have to work with that. And I do see here that I've got some multiplication. So the first thing I'm going to do is I'm going to take the power of 3 to each idea inside the brackets, to the 2, to the x's, and to the y's. So I'm going to say 2, and of course that goes to the power of 3. And then I've got x squared to the power of 3. Then I've got y cubed to the power of 3. I'm also going to separate my 3 and my y to the 4th. 3 and y to the 4th. So what I'm showing you here is that this is essentially multiplication all the way through. Numbers beside letters multiplication, brackets showing multiplication, and because it's multiplication, I can rewrite multiplication a couple other ways. In this case, I'm trying to show multiplication by the brackets. In my opinion, this is going to help me set up my question. So now I'm going to do my exponents. Well, 2 to the 3rd. What's 2 times 2 times 2, which is actually 8. Now I've got x squared to the 3rd. I've got a power to a power here. So I'm going to be multiplying. 2 times 3 is 6. X to the 6. And then I've got y cubed to the 3rd. Power to a power, multiply. 3 times 3 is 9. And then I've got a 3. And then I've got y to the 4th. So what I'm going to do next is I'm going to group my like terms. I'm going to group all my numbers, my x's, and my y's. So this becomes 8 and 3. So 8 from here, 3 from here. Now I can't just simply write 8 and 3 beside each other, because of course that looks like 83. So I have to show you multiplication, so I'm going to use brackets. X's, I've got x to the 6. And that's the only x that I've got. I've got y to the 9th. And I've got y to the 4th. Now I can write these beside each other without brackets because I know letter by letter is multiplication. So now I have to simplify. 8 times 3, well that's 24. There's no other x's, so I just have an x by itself, x to the 6th. And then I've got y to the 9th times y to the 4th. Well, multiplication, same base. I'm going to add these two powers. 9 and 4 is 13. Y to the 13. So I've got a single number, a single x, a single y. So my answer to this question is 24x to the 6th, y to the 13th. Now let's look at the next example. 5xy squared to the 3rd divided by 5x to the 5th y squared. Now there are a variety of ways you could start this, but I like starting mine the exact same way all the time. I see that I've got some power to a power, and I see I've got some division. So I'm going to start with a power to the power, and I'm going to break it out. 5 to the third, x to the third, y squared to the third, all over 5. And let's do a little thinking here. What's the exponent on the 5? Well, there's nothing written there, so I know it's a 1. So I'll go 5 to the 1, x to the 5, y to the 2. Okay, I'm now going to apply these powers to each of them. Now normally I would say let's do 5 cubed and work that out, but I also see that I've got a 5 in my bottom here. So I'm not going to work that out quite yet. I am actually going to write down 5 to the third, x to the 3. This will be y to the 6th. Power to the power means multiplication. Divided by 5 to the 1, x to the 5, y to the 2. Just draw a little line here so you can see the difference between step 1 and step 2. So now I can do some division. And here's why I didn't work this out earlier. This is division with the same base. Base is 5. So if I've got the same base, I'm going to subtract. So this is really 5 to the 3 minus 1. Same base, this is really x to the 3 minus 5. And watch that the numerator is your first number, denominator second. And then I've got y to the 6 minus 2. So 3 minus 1 is 2, so that's 5 squared. 3 minus 5 is negative 2. And 6 minus 2 is 4. Okay, now do some simplifying. 5 squared. 5 squared is 5 times 5, that's 25. X to the negative 2. Well, now you got to think back to a few lessons ago. Negative exponents. We don't like negative exponents. X to the negative 2. Well, you change that to a fraction. Put it over 1. To get rid of the negative sign, I flip the numerator and the denominator. So my 1 comes up, my x goes to the bottom, and my power becomes positive. So essentially what I have to do is bring the x to the denominator. So I'm going to make a line, and I've got x squared in the denominator. Now technically I have 1 in the numerator, but I'm going to times 1 by 25. 1 times 25 just stays as 25. And then I've got y to the 4th. So my final answer here is 25 y to the 4th x squared. Okay, let's go take a look at our next page. So here we're looking at combining some of our previous lessons, in this case our fractional exponents, our radical rules with the exponent laws. So the same process still applies. What do you see going on? Well, I do see I've got some multiplication, all raised to a power. So I'm going to take the 1/3 and I'm going to apply it to the 8, the 3, or the a's and the b's. So this would be like a to the 1/3. This would be a to the 3 times a third. And this would be b to the 6th times a third. Okay, a to the 1/3. Well, we know we're going to change this into a radical. So open up a radical, put the 8 there. The power is 1, which I don't have to write, and my index will be 3. a to the third to the a to the 3 times the third. Well, that's 3 times the third, which is 1, which is really plain old a. B to the 6 times the third. 6 times the third is 2, b squared. Now I can actually work out the cube root of 8. And of course the cube root of 8 is 2, so I get 2ab squared. So in this case, I've applied the exponent, the 1/3, to each set and worked it out. Of course, I'll show you another way you could do this. You could have taken the 1/3 and changed them all into radicals. So you could have had the cube root of 8, that being the index. I could have had the cube root of a to the third, and I could have had the cube root of b to the 6. In this case, the cube root of 8 we know is 2. In this case here, we've got a to the third, cube root. Well, cube root and cubing cancel each other out, gives me with a. And sorry, there should be a 6 here. You take the power, divide by the index, 6 by 3 is 2. So both ways get us where we want to go. Whichever way you feel works, you show your work, get the right answer, you're good to go. Let's go to our textbook. And we can do some work on page 241, 3 from the A's, 5 from the B's, 1 from the C's.